we have this exponential equation, and it's y equals a b to the t. So first we just want to talk about what do the variables represent. The A is going to be the initial population size. That might be, I start off with 100 fish in a pond, and then we start getting more and more fish. So that would be 100. Or it might be I put $100 into a bank account. That would be the A. It's the initial amount. What does it start off being? Okay, now the B value, if that number right here ends up being greater than 1, then you know that it's growing. So like if you had 100 fish in the pond, and then you have 110, and then you have 120, and you have, right, the population is growing. If the population is growing, then this number is going to be bigger than 1. But if the population is decaying, so they're dying off, more are dying off, fewer and fewer are in there, then this number right here is going to be smaller than 1. Okay, then after that, if I want to know like how fast is it growing or decaying, like if it's getting growing 50%, by 50%, it starts off at 100, now it's at 150, right? It's growing, what percent? Then B also helps us to find how fast it's growing, but when it comes to a growth, the number sitting there is 1 plus the rate as a decimal versus 1 minus the rate as a decimal for decay. That part's a little trickier, so it'll be easier to just show you with some examples. All right, so let's start off with this example here. We have a study. It's being done on a population of a certain fish species in a lake. Suppose that the population, P of t, after t years is this equation. Find the initial population size. Well, if I know what the variables stand for, then I know that this 200 right here is the initial population. So in other words, in the lake, originally there were 200 fish. Okay, then does the function represent a growth or decay? Meaning, as time goes by, are there more and more fish or less and less fish? So where we look is this number in parentheses. Since this number is greater than 1, this is a growth. Now we want to specifically find the percent of growth. So we're going to take the 1.32, that B value, and subtract 1, and I get 0.32, but this is not a percent. 0.32, if I want to change a decimal into a percent, I want to multiply by 100. So if I take 0.32 times 100, that ends up being 32%. Okay, so let's just do one more. Okay, so in this one here, we have a deli sandwich is placed inside of a cooler. As the sandwich cools, the temperature C of t in degrees Celsius after t minutes is given by this equation. What's the initial temperature of the sandwich? Okay, so whatever number is the A, okay, so that's this number right here. It was originally 19 degrees Celsius. Okay, then we want to know, is this representing a growth or a decay? This number right here, this time is smaller than 1, so that tells me that it's a decay. All right, and then after that, by what percent does the temperature change per minute? We're going to get at that using that 0.87, but this time, instead of doing the number minus 1, we're going to have to do 1 minus this number. So it's important that you know when you have a decay, you're going to do 1 minus to get the percent. But if you have a growth, you're going to take the number minus 1. All right, so let's go ahead and subtract 1 minus 0.87. I end up with 0.13. This is not written as a percent, so to turn that into a percent, I multiply by 100, and so the decay rate is 13%.